Suppose you have A, B, C, D, 4 items, and the question is, how many ways can you choose 2 items? Now, we did do a similar question last time, which was, how many ways can you permute 2 items out of 4, right? So recall 4P2 was number of ways to choose 2 items out of 4 and permute. Okay. So these two look very similar, but the one that we did had this idea of permuting. So in other words, when you chose A, B, whether the order was A, B, or B, A, are treated as different in this question, okay? When you do permutation, the order matters. Different orders are treated as different. But here, I didn't talk about whether A and B being chosen means, it doesn't really care where A is chosen first and then B, or B is chosen first and then A. The order doesn't matter over here. So that's the big difference between them. And because if you choose 2 items, there's always A, B, or B, A. Like there are 2 ways to flip any choice of 2. Things that are counted here, when you throw away the ordering, becomes a single thing over here. Okay? Yeah. So the answer is, the answer would be, you just do 4P2 like before, but we divide it by 2 because we are ignoring the ordering. And therefore, well, what's 4 choose 2? That's 4 times 3, that's it, right? And then you divide by 2, so that's going to be 6. And indeed, when we were doing power sets, when we had like power set 1, 2, 3, 4 with 4 items, and we had to list all the items in the power sets, we had 6 items, right? Yeah. You can even try it out. So solution 2, you can solve the same question by explicitly writing down what are the 2 choices. It could be AB, AC, AD, or BC, BD, or CD. That's all. Okay. No matter what you try, if you picked 2 items, then it'll be one of these 4. Okay. Now, if you chose BA, that's same as AB because here the ordering doesn't matter. Okay. So the second solution would get the same answer by actually listing out everything. All right. So in either case, what we just observed is the following: that 4 choose 2 is equal to 6. Okay. So we were learning this new symbol. Before it was 4 permute 2. Now it's 4 choose 2. Because this is called combinations, and I usually just think of C as choose 4 choose 2. But because this appears so many times, it's customary to use 4 and then 2 as a parenthesis as the same thing. So there's another symbol for 4 choose 2 is people write it like 4 and 2 like this. Okay. Both are pretty standard notations. 4 choose 2 or 4 2 like this. Okay. All right. So now let's try something harder. What if we have, say, 1 through 6? Okay. So 6 cards. Okay. So question is, how many ways can we choose four items? Four items out of six. So let's think about that. So one way to do it is, again, do 6 permute 4. Okay. And that's nice because we already know the formula for this. So remember, the formula that we discussed last time for NPR is n factorial divided by n minus r factorial. So if you apply this formula over here, this is going to be 6 factorial over 6 minus 4 factorial. So that's going to be 6 factorial over 2. Let's see, 6, 5, 4, 3, 2, 1 divided by 2. And that's going to give me, what, 30 and then 12, 360. Okay, but that's permutation. This would, for example, if you have 1, 2, 3, 4, and 1, 2, 4, 3, or 3, 4, 1, 2, all of these are going to be treated differently in 6P4, whereas for this question, for the purpose of this question, all of these should be treated as the same. Okay? Because we're not thinking about ordering. If four things are chosen and whether if you choose one by one, the order came out to be this way or this way or this way, we don't care. Okay? They're all considered same in this question. So what do we do? Well, what we do is think about all the different ways this 1, 2, 3, 4 would be represented in 6P4. So now the sub-question is, so there are 360 ways to permute 4 items from 1 through 6. Okay? Now, question here is, in this set, 1, 2, 3, 4, this choice is represented in how many different ways? So that's the question that you should be asking. Well, what does that mean? You have 1, 2, 3, 4, 1, 2, 4, 3. You can either try to do dictionary ordering, it takes a while. 1, 3, 2, 4, 1, 3, 4, 2, and then 1, 4, 2, 2, 3, 1, 4, 3, 2. Then you run out of everything that starts with a 1, and then you can start with 2, 1, 3, 4, 2, 1, 4, 3, 2, 3, 1, 4, 2, 3, 4, 1, 2, 4, 1, 3, 2, 4, 3, 1. All right, and then you can do another one that starts with the 3. And I think there's a pattern here. There's a 6 of these, 6 of these, another 6 of these, and then the one that starts with 4, another 6 of these. So how many do you have? 24. And all these 24 is regarded as a single thing for the purpose of just finding out for choosing 4 items, right? So what should you do? To get the answer for this one, you should take 360 and do what? Divide by 24. If you divide by 24, it's a 24 to 1 math. Like the forgetful math that forgets the ordering takes 24 different items and thinks of that as a single thing, right? So after this observation, so the answer to this smaller question is 24, and therefore the answer should be 360 divided by 24. And what is that? That's 30 over 2, which is 15. That's how you do it, right? Okay. So if you think about the previous case, so here, this is what we're doing for this one. We're doing 6 permute 4 divided by 24. Now, the one that we did previously, when we did 4 choose 2, we had 4 permute 2 and divide by 2, right? And here what we're doing is 6 choose 4 is same as 6 permute 4, but divide by 24. So both seem to be giving us a similar way to solve, which is that if you do 6 choose 4, then you're doing 6 permute 4, but then you have 4 items, and the number of ways that you can permute 4 is 4 factorial, isn't that right? The number of ways that you can permute 4 items is 4 factorial, so you're dividing by 4 factorial. Here, if you choose 2 items, then the number of ways that you can permute 2 items is 2 factorial. So after doing this and doing a few more examples, you get the following identity, which says if you do n choose r, that's going to be n permute r divided by r factorial. Furthermore, because we know the formula for NPR, what is that? NPR is n factorial divided by n minus r factorial. And dividing by r factorial, that's same as, if you simplify this, the same as n factorial divided by r factorial and then n minus r factorial. So that's the formula. The formula for NCR, also known as n choose r, is n factorial, r factorial, n minus r factorial. Now, one thing you should observe from here is that if you did NC n minus r, then that means r is replaced by n minus r, so you get n factorial divided by n minus r factorial, and then n minus r factorial, so that you get n factorial over n minus r factorial times r factorial, because n cancels, minus is plus. Oh wait, but this is the same as the original one, so this is the same as NC n minus r. Just r, NCR. So there's some kind of symmetry. Second example again. Here's how the symmetry works. So example 2, I'm just rewriting the question again. How many ways to choose 4 items from 6 items? So that's the question that we had just now, right? But choosing 4 items is same as excluding 2 items. Does that make sense? Yeah. So if you have 1, 2, 3, 4, 5, 6, and just think about choosing 2 items. So in the first stage, how many choices do you have? 6 possible choices, right? And then in the second stage, you choose another one, but you have 5 left, so you do 6 times 5. However, there's whether you choose 1 first and then 2, or 2 first and then 1, that's not anything different, right? So this actually double counted everything. So you have to divide it by 2, so you get 15. So by doing this, we get the same result. 6 choose 4 is indeed 15, but the way we did this was we didn't really count 6 choose 4, we really counted 6 choose 2, because we figured out ways to choose 2 items from 6. So we see that 6 choose 4 and 6 choose 2 are the same, and that's because 6 minus 4 is 2. That's what this identity is saying. NC n minus R is same as NCR. Okay? So here's the important formula that you have to know, and here's a symmetry of the formula. And you could prove this by thinking of examples, but in general, what this is saying is that choosing R items out of N is same thing as excluding N minus R items from N. That's what it is. Okay?